Hello, everyone. Good evening from New Zealand. Welcome to my session. I'm the presenter today. My name is Yuanyuan Hu, a third-year PhD student from the University of Auckland. Dr. Claire Donald and Dr. Nasa Jackman are the co-authors of this research and also my PhD supervisors. It's my first time here in LUC, so I must firstly express my thanks to the LUC 20 organizers to make this online conference happen. So let's start. So our session, sorry. So our session reports on early stages of a doctoral thesis project. The main goal of the final research is to build an automatic classifier of cognitive presence in MOOCs that could be used to facilitate and assess effective online learning on a large scale. So the early stage of this goal should be looking for a valid and reliable rubric to classify cognitive levels in MOOC discussions. Therefore, this session will introduce how the phases of cognitive presence were manually coded in preparation for training automatic cognitive classifiers. Today, I'm going to talk about 6 sections. I'll begin with introduction of context and main problems, and secondly, about research questions, and then back to introduce the theoretical frameworks and terms. After that, I'll report our methods, research results, and finally, summarize findings and main contributions, as well as our future plans. So our research story started with a challenge caused by a shift from the traditional small-scale full-credit university courses to global open learning platforms such as MOOCs. MOOCs have 3 distinct attributes arise the challenge. They are massive, open, and online. Massive means there are a massive number of participants in MOOCs. And secondly, the access to MOOC content is open regardless of university entrance barriers since the majority of educational content is free. Therefore, massive learners enrolled in the MOOC are extremely diverse in terms of age, occupations, study majors, academic and cultural backgrounds, etc. At the same time, it arises a new learning way, autonomous and self-regulated way in the fragmented informal learning environment. So the massive numbers of learners from diverse backgrounds, they have different motivations, they generate massive amount of data. All these attributes drive learning designers and researchers in learning analytics to face a significant challenge, that is, looking for effective assessment and remediation of students learning on large-scale courses such as MOOCs. Since the main goal of our research is to build an automated classifier of cognitive presence in MOOCs that could be used to facilitate and assess effective online learning on a large scale. So the early stage of this goal should be seeking a valid and reliable rubric to classify cognitive levels in MOOC discussions. Unlike face-to-face courses, MOOCs offer a virtual place for teachers and learners to communicate and interact. That's the asynchronous online discussion forums. For 2 decades, scholars found evidence that online discussion forums can provide instructors and course designers with insights into learners' higher order thinking and cognitive engagement. They developed content analysis frameworks, methods, and measurement tools to evaluate cognitive engagement in live discussions. The most widely used framework is the community of inquiry model and its preliminary dimension, cognitive presence, which we will illustrate precisely afterwards. So the table here are the recent studies that analyze the phases of cognitive presence in online discussion messages. They all applied classification rubric developed by Garrison, Anderson, and Archer in 2001, and they all reached high internal reliability. There are also promising studies that develop automated classifiers to analyze cognitive presence levels based on the above manual classified datasets. However, look at the datasets and context. The second column, we can see that all of them focus on small-scale, full-credit university courses. So here comes the gaps. Do Garrison, Anderson, and Archer's classification rubric of cognitive presence only cater for online full credit and small-scale university courses? According to the gap, here comes our two research questions. The first one, can the cognitive presence classification rubrics developed by Garrison, Anderson, and Archer in 2001 be used to manually classify learner discussion messages from a target MOOC in a valid and reliable way? And also the research question 2, can the manual classification results be reliable training data for developing automated classifiers in future research? So after introducing our research questions, I'm going to talk about the basic theoretical frameworks and terms. What is cognitive presence? As we mentioned, the community of inquiry model developed by Garrison, Anderson, and Archer in 1999 is the most widely used framework to analyze online discussions in the past 2 decades. It describes the educational experience, including self-learning and collaboration between teachers and students. All of this learning engagement occurs in a virtual community with 3 dimensions. There are cognitive dimension, social dimension, and teaching dimension. So the cognitive presence from the community of inquiry model represents the critical reflection of knowledge construction, reconstruction, and also problem-solving processes and the learning community we just mentioned. Garrison, Anderson, and Archer also proposed that there are 4 phases of cognitive presence from learner's side. Like the figure on the right shows, their hierarchical structure. So during learning, the process of cognitive presence begins with the first level triggering events, and then goes to exploration, and then integration, and the highest level resolution. However, the definitions of 4 phases in Garrison's study and their descriptions originally created for small-scale, full-credit online courses, not for MOOCs. Therefore, we keep the name of each phase, but redefine them for categorizing MOOC discussions. So, in our definition, the triggering event, the first level, means like during learning, you found a problem. You are not happy, but you don't know why. And then you attempt to look for more information to diagnose the problem. You like to know what caused the problem, how can it happen? So this is the second level exploration. Then after learning, reading, thinking, discussion, you reach a coherent conclusion or create a reasonable solution. That's the integration level, the third one. After that, you like to apply or test the conclusion or solution in real life. You may propose new and relevant problems. That's the highest level resolution. Besides these 4, we added a very beginning level non-cognitive presence. So if posts relate to other dimensions of community of inquiry model, for example, social and teaching presence in the rubric. It do not fall into any of the above categories. That's the non-cognitive presence level. For the classification rubric of each cognitive phase, we firstly applied the most widely used one offered by Garrison, Anderson, and Archer in 2001. According to their rubric, we found many messages in our target MOOC cannot be put into any of the levels. Moreover, the descriptions of some indicators are ambiguous and some are too brief, especially for the highest level resolution. These problems drive our human raters confused. So we adjust the rubrics by combining PARCS, which developed in 2009, PARCS manual classification scheme in 2009. So, and we also summarized some new indicators from our manual classification tasks. So the new version are listed on the slide. The gray part are the original indicators from Garrison, Anderson, and Archer's scheme. And the highlighted ones, the orange ones, they are either PARCS or the new indicators summarized by us. Due to the time limitation, so I just briefly introduced our classification rubric. So if you are interested in the details, we can talk about it later. The target MOOC in this research is the Logical and Critical Thinking MOOC on FutureLearn platform. This MOOC was designed and taught by a team from the University of Auckland. So in each run of the MOOC, there are 8 weeks. And in each week, there are different learning steps, learning tasks for a learner. In each run of the MOOC, the average enrolled users is around 11,000, and the comments of 8 weeks in total is around 12,000. So our sample data in this research is 1,002 messages, including posts and comments. We randomly selected from an archive run of this logical and critical thinking MOOC. Our 2 raters are postgraduate students from the philosophy department and also the teaching assistants of the target MOOC. We selected 200 messages for training them after they achieve over 80% agreement. We allocated the 1,002 messages for them to categorize into the 5 cognitive levels according to our new rubric mentioned in the previous section. So here comes the results. So they've reached 95.4% agreement between these 2 raters, and their sample data is 1,002, as I mentioned. And also, the right figure shows the distribution of agreements across 5 categories between these 2 raters. As we can see, the highest proportion is the exploration, the second one. Despite of the percentage agreement, we have another measure of inter-rater reliability between these 2 raters. We have Cohen's kappa coefficient. So they reached average, the Cohen's unweighted kappa 0.932 and Cohen's weighted kappa of 0.96. I think this results shows a higher reliability, inter-rater reliability between these 2 raters. And the right figure is the confusion matrix of the 2 raters. So the vertical axis as the rater 1's decision across the 5 categories, and the numbers are the number of the messages, and horizontal axis as the rater 2's decision across the 5 categories. So the diagonal, the orange cells, are the agreements between these two raters. So despite, let's look at the confusion matrix again. So despite these results, we also have another interesting finding. Look at the cells in light orange color. They are the disagreements between the two raters. It seems that they only appeared on adjacent faces of cognitive presence. So what does it mean? Could it mean there may be some additional categories existed between cognitive phases in the MOOC context? So finally, let's quickly summarize the conclusions and think about future plans. Firstly, we gained the answer to our research question 1. Our research findings so far suggest that we have a sufficiently reliable and valid rubric to continue our research. We also have another interesting finding about the disagreements is that most of the confusions by human raters appeared at adjacent phases of cognitive presence. Therefore, we assume that additional categories may exist between cognitive phases and MOOC context. As for research question 2, we actually focus on what to do with the disagreements data rather than agreement data. If data set is small, the number of disagreements is small as well. But if the data set is in huge volume, we cannot just ignore them. So therefore, one of our next steps will be to cross-validate the use of our adapted rubric by a third rater to see if the reliability will decrease or not. Another important point is another purpose of applying machine learning techniques in educational research should be to pinpoint research bias that scholars might never intend to, or we cannot found without computer support. So our next goal is to develop automatic classifiers that not only cater for agreements, but also consider the disagreements between human raters. I also list the key reference here. So that's my presentation today. Thanks all for your patience and interests. We welcome your questions and comments. Please also keep safe and healthy during this special time. Thank you.